Okay, so today in this session, we are going to start and do the organic past paper questions. So let's start. If ready, you can drop in the chat or you can WhatsApp me. Okay. So let's start with question number 1. In this question, alkenes and cyclic alkanes should be considered. How many structural isomers of C4H8 are there? Okay. So here in this question, you have to consider alkenes and cyclic alkanes both. Okay. And you have to figure out how many structural isomers can be formed of this formula C4H8. So if we work for it, let's talk about C4H8 as I have discussed with you. If you recall, if you look at its formula, we can conclude from this that its general formula is CnH2n, right? And CnH2n are basically, there are two kinds of organic compounds which have a general formula of CnH2n. One can be alkene and the other can be cyclic alkenes. Okay. Now let's start with C4H8. So if I will draw the skeletal formula, you can look over here. 2 carbons, 3 carbon, 4th carbon, and 1 double bond. It's butanene, right? So this is the one isomer. The other possibility is this, that this double bond shifts its position and we will draw this one. So this is second isomer, which we can name it as a butene, right? Then there would be a third possibility in which there are 3 carbons are in the longest chain and the 4th carbon is the branch and a double bond. So we can name it as 2-methyl propanene. So these are the 3 structural isomers which are actually alkene. Now let's move to the cycloalkanes or cyclic alkane structure. So one can be a cyclobutane in which all the 4 carbons are making a one closed chain ring. Is this understandable? And there is a second possibility which can be a methyl cyclopropane where 3 carbons making a cyclic ring and 4th carbon exists as a side chain over here or any one of the carbon. So see, if you look over here, 1, 2, 3, 4, and 5. Beside these 5 structures, there is no other possibility of any other alkene or cyclic alkane which have a molecular formula of C4H8. So that's why I can mark A, B, and D wrong. And my correct answer is C. Is this understandable to everyone? Yes, if anyone have any doubt, do ask. Okay. Now, question number 2. Which compound will decolorize aqueous bromine? Okay. So, if you recall, aqueous bromine, among all the organic compounds, aqueous bromine can react with alkenes only. No other compound, okay? They reacts with alkene only. So we have to figure out in which compound there is a carbon-carbon double bond or in which compound there is an alkene. And whenever we say alkene, it means there is a carbon-carbon double bond in the structure. Okay, so if you look at the first structure, here we have CH3, CH2, CH2, CH2. All the CH2 are there, and there is no carbon-carbon double bond, so A goes wrong. Again, CH3, CH2, 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 no double bond. CH3, look at CH and CH. So if you consider it, and if I'll draw it as CH3, then CH. After that CH, there must be a double bond, and then there is a CH again, because both have CH. And then we have a single bond CH2. So yes, this can be our answer. If you look at the last one, we have a CH3 and then CH2s only. So D is not considered as answer. It is also wrong. So C is our correct answer. Is this understandable to everyone? Okay. Now, question number 2. Sorry, it's question number 3. Alkenes react with aqueous hydrogen bromide. Okay. HBr, and alkene refers to carbon-carbon double bond. The reaction proceeds via an intermediate carbocation. Okay. The more stable the intermediate, the faster the reaction. Okay. See, they have given you this information, and no, I'm not sure. Okay, just leave this. So they have given you that the faster reaction occurs when there is a more stable intermediate. Which sequence correctly shows an increase in the speed of a reaction of the alkenes with hydrogen bromide? Okay, so let me recall you. Most stable is the tertiary carbocation. So if I make the order from fastest, then I can consider tertiary is the fastest. Tertiary would go on this reaction fastest. Secondary would go with the intermediate rate or a moderate rate, and slowest, the primary carbocation would undergo this reaction with the slowest rate. Is this understandable to everyone? Okay. So if we start from A option, so in A option, it's an ethene, right? So ethene would be C double bond C, and there are 2 hydrogens on the first carbon and 2 hydrogens on the second carbon, right? So when it makes an intermediate, what would happen? That one carbon get a hydrogen, and they ask you show. Okay, read the question again. Which sequence correctly shows an increase? So we have to go from the slowest to the fastest. So here we could get this as a primary carbocation. So if you look at this structure, the carbon which becomes a primary carbocation is the primary one, right? Then we have propene. So if I'll draw propene over here, CH3, then CH double bond CH2. So what would happen when the reaction proceeds, and when we get the intermediate, the hydrogen bonds to this carbon, and this carbon become a positive carbocation. So here this makes it a secondary one, right? Now we are left with 2-methyl propene. So if I will make 2-methyl propene, so it would be CH3, C, CH3, and double bond CH2. So when the reaction proceeds and the carbocation the intermediate carbocation would form. So here we get a hydrogen, and this carbon becomes the positive one. So if you look at this one is the tertiary. So if I will talk about their speed, by the information that examiner provided me over here, the more stable the intermediate, the faster the reaction. So the more stable would be this one, most stable, right? So this one undergo fastest, and this one would undergo with a moderate speed because it's a secondary, and this one would undergo with the slowest speed. So that's what examiner is asking, show which sequence correctly shows an increase, right? So here in this we are getting a shows an we are getting the or we are observing an increase in the speed of reaction, A option only. So it means A is correct. We don't have to look at the other options. Is this understandable? If anyone have any doubt, do ask, please. Yes, is this clear? So if I mark the speed, this one undergoes slow, this one with a medium speed, and this one with the fast speed. See, we have only these three compounds. So this one would go fast, then slow, and then medium. This makes B wrong. Here, it goes with a medium speed, then slow, and then fast. That's why C is wrong as well. Then medium, propene with a medium speed, 2-methyl propene with the fastest speed, and ethene with the slowest speed. This makes D wrong as well, okay? I hope is this understandable to everyone? Now, question number 4. A reaction occurs when a sample of 1-chloropropane is heated under reflux with a sodium hydroxide dissolved in ethanol. So see, sodium hydroxide dissolved in ethanol. This thing, if you recall, this sodium hydroxide in ethanol leads to elimination reaction, right? And if the reaction is elimination, then on the basis of that, I can mark C and D wrong. And we have a 1-chloropropanol. So there are 3 carbons, propanol. On first carbon, we have a chlorine. So when this reaction occurs, elimination would take place. The chlorine from the first carbon and the hydrogen from the neighboring carbon would remove, forming propene. So see, here elimination and propene, and in A elimination is right, but the product they are saying propane 1 all is wrong. So A goes wrong and B is our correct answer. Is this clear to everyone? Yes. It's elimination. When sodium hydroxide is with water, then substitution would occur, and we also called it hydrolysis as well. Okay. Now, question number 5. Okay. The diagram shows the structure of the 3 halogenoalkanes. P. If you look at P, a carbon which is bonded to functional group have 1, 2, 3 methyl groups. This makes it a tertiary halogenoalkane. A carbon bonded to a hydrogen have all 3 hydrogens. This makes it a primary halogenoalkane. And a carbon bonded to a chlorine again have a hydrogen. So it is also a primary halogenoalkane. Now what they are saying that P, Q and R can all be hydrolyzed. Okay. Which row is correct? First, they are asking about the relative speed of hydrolysis. So Which one will actually undergo with the fastest speed is the tertiary one because it forms the stable carbocation. One minute. Okay, they are talking about, when they are talking about speed, they are talking about Q and R. So if you recall, the carbon bromine bond is have a greater bond length and carbon chlorine bond length is smaller. So this makes this bond weaker and this bond is stronger. So if the bond is stronger, then it would take, more time to broken down, and this one would take less time to be broken down. So this would occur with a faster rate and this would occur with a slow rate. That's make Q go fast, not slow. That's make C and D wrong. Is this understandable to everyone? Okay. Now, mechanism of hydrolysis. So if you recall, whenever there is a tertiary one, which is P, so tertiary one would undergo SN1 mechanism, where carbocation would form first and then the nucleophile will attack. And primary one would undergo SN2, where the nucleophile attack on the carbon before the formation of carbocation as an intermediate would form. Transition state as is an intermediate. So here they are saying that P is undergoing SN2, which makes option B wrong. P would undergo SN1 mechanism because it's a tertiary, and Q would undergo SN2 mechanism because it's a primary. So our correct answer is A. Is this clear to everyone? Yes, Abdullah. They both are primary, so we can easily consider it by the bond energies. Okay. If anyone have any issues in this question, kindly ask. Now, question number 6. Which compound gives both orange precipitate with 2,4-D pH and a yellow precipitate with alkaline aqueous iodine? Okay, so let me recall you 2,4-D pH. The orange precipitate with 2,4-D pH would be observed when any aldehyde or ketone was present. For aldehyde, the structure must have a C double bond O, and that carbon must be bonded with a hydrogen on one side. And for ketone, there must be a C double bond O. No, that's wrong, Abdullah. And on both sides, there is a carbon. Okay. And for aqueous alkaline iodine, any aldehyde having C double bond O, which is bonded to a CH3, this group can be present in any aldehyde or ketone, then this would undergo this test positive. And for alcohols, any alcohol which have a CH3 and on its neighboring carbon, there is an OH and at least one hydrogen is there, then that kind of alcohols would give this test positive. So alcohols are not going to give you 2,4-D and pH test positive. That's why if there is an alcohol, that goes wrong. Okay, so A is not our answer. Now, let's have a look at methanol. Methanol means there is one carbon only. So the structure would be this. So see that C double bond O is not bonded to CH3, as that is a prerequisite condition for test for those compounds which are giving yellow precipitate with aqueous alkaline iodine. So B goes wrong. Now, and why it is wrong? Because there is no CH3 adjacent to CH3 for this molecule. If I'll make propanol over here, so propanol is CH3, then CH2, then C double bond OH. So again, this condition also fits on propanol because C double bond O is present in the compound, but the carbon which have a C double bond O have no CH3 on its adjacent, on its neighbor. There is a CH2, right? So C goes wrong. It means we are left with the D option. So our correct answer would be D in this case. Is this understandable to everyone? If I'll draw D over here, so see, propanol. Prop means 3 carbons. There is a C double bond O because propanon. So both the carbons have CH3. So there is a C double bond O, and on its adjacent there is a CH3. So yes, this is a key in pH, and this is a methyl ketone where the carbonyl is adjacent to CH3. This is carbonyl, and here we have a CH3. These two are adjacent and bonded with each other. That's why it gives you aqueous alkaline iodine test positive and shows a yellow precipitate with aqueous alkaline iodine. So that's why our D option is correct. Is this understandable to everyone? If anyone have any doubt, do ask me, please. Okay. Now, question number 7. A student suggests 2 uses of LiAlH4. So let me recall you, LiAlH4 is what? It is a reducing agent. Okay. It is a reducing agent, can reduce, and to which compounds can be reduced by this? Any carboxylic acid. You have to remember this. Number 2, aldehyde and ketone. Number 3, if there is a nitrile. And number 4, if we have amide as well, C double bond O is bonded to NH2. And these are the compounds which can be reduced by LiAlH4. Okay. C triple bond N nitrile. Okay. So what examiner is asking, in reaction 1, there is an alkene, and alkene is turning into alkane by LiAlH4. So this can be correct? No, this cannot be correct because I have just discussed with you which compounds can actually reduce by LiAlH4. In this, if you see, there is a carboxylic acid, COOH, which I have mentioned, turning into an alcohol. So yes, this is correct. Which reaction would give the product shown? No, not B. Neither reaction, that is also wrong. So C is correct answer. Now, remember, whenever we are talking about these, when it undergo reduction with LiAlH4, you are going to get primary alcohol. Okay. What you are going to get? Primary alcohol. Same with the aldehyde. When aldehyde undergo reduction with LiAlH4, you will again get primary alcohol. When ketone undergo reduction with the LiLH4, you will get secondary alcohol. When nitrile undergo reduction, you will get amine. And when amide undergo reduction with LiLH4, you will get amine. And what is amine? A carbon is singly bonded to NH2 or a nitrogen, then it's an amine. Is this clear to everyone? If anyone have any question to ask. Okay. Now question number 8. What is the least number of carbon atoms in a non-cyclic alkene molecule that has a chiral center? What they are asking? They are asking about the least number of carbon atom. And what is the least number over here? 7. So let's try to make a structure from a 7 carbon, whether I am going to get a chiral center or not. Okay. Then we will move to the next questions, next options. Okay. So if I have a 7 carbons, let me think this carbon can be chiral. So there must be 1 carbon. In this case, I have a 2 carbons over here. So how many carbons I have put it? Here, for example, I have a hydrogen. I have put it 4 carbons. Now I am left with 3 carbons, right? So 1, 2, 3. So see, on one side there is a chain of a 3 carbon atom. On the other side, there is a chain of 2 numbers are different. So, and this is the smallest number, and it is forming a compound, a structure which have a chiral carbon. So yes, it is my answer. This is the correct answer. And the rest of the option would wrong. Obviously, they would make a chiral center. Their structures can also have a chiral centers, but these are not the structures with the least number of carbon among these options, because the smallest number is 7. Is this clear? Mehveen, it's not a paper, it's the combined questions of organic only. Because from organic, if you look at the any one of the paper, you are going to find around 12 to 15 MCQs from organic only. So that's why these are the compiled questions of organic only. Okay. Now, question number 9. A molecule of a polymer contains the sequence shown. Which monomer could produce this polymer by addition polymerization? Okay. So remember, whenever there is a carbon chain, so mostly the carbon chain have a 2 carbons from one monomer only. So it means this is the part of the monomer, and this is the part of another monomer. This is the part of another monomer, and this is the part of another monomer. Okay. So if I make it individually, I have a 2 carbon atoms. Out of these 2 carbon atoms, 1 carbon has two hydrogens. The other carbon have 1 chlorine and 1 hydrogen. If you look at any one of the structure, whether 1, 2, 3, 4, 5, or 6, you will find this thing is common, that there are 2 carbon atoms. And out of these 2 carbon atoms, 1 atom have a 2 hydrogen and 1 atom have a 1 hydrogen and 1 chlorine. Yes, Abdullah, good. Then if I have to make the monomer, so what I will do, I will put a double bond and remove the bonds from the sides. So this is my monomer. And if you look at this, here we have a H and Cl on both sides. This makes this wrong. Here we have a two hydrogens on one side and H and Cl on the other side. This makes this wrong. Then CH3, there is no CH3. This makes C wrong. Again CH3, this makes D wrong. So our correct answer is B. Is this understandable to everyone? Okay. Now, compound Y is heated with mild oxidizing agent. One of the products of the reaction reacts with hydrogen cyanide, forming 2-hydroxybutane nitrile. Okay. So the product is reacted with hydrogen cyanide. So if you recall, hydrogen cyanide reacts with aldehyde or ketone. Okay. And Y on oxidizing with mild oxidizing agent giving us Y, and Y is reacting with HCN. So what I can conclude, 1 minute. See, I don't know, there is a compound X which when reacted with mild oxidizing agent, it would give me Y, and Y with HCN undergo a reaction. So from here, what I can conclude about Y, that Y is either aldehyde or ketone. And if Y is aldehyde or ketone, then it clearly means that X can be an alcohol. Okay. And here what we are getting, when it reacts with HCN, that is another important thing. We are getting 2-hydrox. It's a butane, which means 4 carbon atoms, right? So see, 1, 2, 3, 4. On second carbon, I am getting an OH, and it's a nitrile. So CN is there. So from this, if I go backward, then I can easily figure out that this would be Y, which is a butanone. And if it's a butanone, then if I get backwards towards X, so what I will able to get, that it is an alcohol with a, no, sorry. This is an aldehyde with a 3 carbon atom, because CN is coming from here. So the 4th carbon is coming from here. So Y is propanol. And if Y is propanol, then it clearly means that X is a propanol and propane 1-ol. So that's make A, B, and D goes wrong. And my correct answer is 10. Yes, is this is C, which is propane 1-ol. Yes, is this clear to everyone? Yes. See, we are getting, see what will happen over here. When the HCN would react, we are getting this compound, right? So it means I have to remove this H and this CN from here to get this. So if this H and this CN would remove, then we will get this one, which is an aldehyde. So if I reduces aldehyde back. So I am going to get an alcohol with a 3 carbon atoms where the OH group or a hydroxy group is on the first carbon. So that's how I have concluded that my correct answer is propane 1-ol. Yes, Maveen, is this clear? Because H and CN are coming from this. So when I move backward from the product that they have given me, 2 hydroxy butane nitrile, so I would remove CN and H, then I would left with an aldehyde. That's what I have told you initially, that see, hydroxy nitrile is always from aldehyde and ketone. So obviously this means that Y is an, sorry, it clearly means that the product that is formed from Y. Okay, I just did a wrong thing over here. This is Y and this is X. So I could clearly identified that the product that is this product is basically aldehyde or ketone. From this final product, I concluded this thing. And if it's an aldehyde and ketone, then it clearly means that this compound Y is an alcohol. Because aldehyde and ketone in our syllabus is only prepared from alcohol only. Is this clear? Now, question number 11. The diagrams show the structure of lycopene and beta carotene. When lycopene is converted into beta carotene, what is the gain or loss of hydrogen atoms per molecule? Okay, so if you look at these two, the change is occurring at this region only, right? Or actually at this region instead, because the double bond is also not there over here. So here we are getting the change, right? The parts which I have highlighted. Now, look over here. Oh, sorry. There is a 1 hydrogen over here. And on this carbon, there is no hydrogen. And here, if you see, there is a 1 hydrogen. If you look here, there is no hydrogen now because there are all 4 bonds. In the same way, there is no hydrogen. But if you look here, there are 2 hydrogens. So if they are talking about gain or loss of hydrogen, so there I can say that no gain and no loss, right? Because there are 2 hydrogens on 2 different carbons. Each carbon have a 1 hydrogen. Now, out of these 2, 1 carbon loses the hydrogen and the other carbon gains the hydrogen. So in the molecule, the number of hydrogens remain same. So if they are saying 4 gained wrong, B 2 gained wrong, no change is correct, and 2 lost, which is also wrong, because the hydrogens that are lost from the 1 carbon is gained by another carbon. So there is no change in the hydrogens. So C is our correct answer. And that same thing is taking place on the other side of the molecule as well, because if you look at the whole molecule, it is asymmetrical. Is this clear? Yes. If anyone have any question to ask, kindly ask. Okay. Which diagram shows the infrared spectrum of a compound that contains both C double bond O and OH? So if you recall that C double bond O normally comes at from 1600 to 1800 and its peak is like this only. And if you recall, OH varies from 2500 to 3000 for carboxylic acid, which is a very broad peak like this. And from 3200 to 3600, still a broad peak. So if you see here, there is this broad peak is missing. So A goes wrong. This broad peak is missing over here in C. This goes wrong. Here we are getting this broad peak, but from 1600 till 1800, there is a no peak over there. So D goes wrong. C, here you are getting the peak of C double bond O. And here you are getting the broad peak from 2500 to 3000 of OH of C double OH. This makes B your correct answer. Yes, Abdullah, good. Is this clear? Okay. So see, now in this way, they have give you these ranges, so you can compare these ranges to identify. Okay, now look at question number 13. One molecule of ammonia, NH3, reacts with one molecule of ethyl methanoate. Here we have the formula to produce one molecule of methanamide. Okay. And only one other molecule X. Okay. So if I will make the equation over here, see, NH3 is reacting with HCO2, C2H5, and they have given us one product C. From HCO2, HCO is left, and there is a NH2 over here. So what is removed from HCO2, C2H5? C2H5O is removed, and the hydrogen from here is removed, which obviously going to bond with this O. So the other product would be ethanol, right? Okay. Okay, let me write over here. It's missing. It is hydrogen monoxide and it is hydrogen cyanide. Okay. Now, what they are asking, one molecule of methanamide decomposes on heating strongly to produce one molecule of ammonia and one other molecule Y. What could be the identities of X and Y? So X, we have figured it out that X is ethanol, right? So here X, this cannot be X, so B and B goes wrong, so we are left with C and D. So if I heat HCO2 NH2, so they are saying one molecule of ammonia, so NH3 would form. So if NH3 is formed, what is left? CO2 is left, right? Okay, it's not, sorry. It's methanamide is HCONH2. 1 minute, Ubaid, I'm coming to your question. CONH2. So NH3 is formed. The leftover is carbon monoxide. No, okay, I have wrong. It's carbon monoxide. I have written wrong. So C is your correct answer and D goes wrong. Yes, Ubaid, can you ask what you want to know? Yes, C double bond OH have a more broader peak. then carboxylic, then see the pH is, the peak is of OH, Mahveen. There are two kinds of OH. One is of alcohol. See, okay. See, there are two kinds of alcohol. One is OH of alcohol. Okay. Remember, OH of alcohol shows you peak from in the region of 3200 to 3600, and it is like this, a broader peak. Okay, Mahveen and Ubaid. And there is another OH of carboxylic acid, because COOH also have an OH. This peak showed up in the region of 2500 to 3000, and this peak is like this. So the OH of carboxylic acid have a broader peak than alcohol, than OH of an alcohol. Is this clear? Yes, Ubaid and Mahveen? Okay. Is question number 13 clear to everyone? Yes, is question number 13 is clear to everyone? Now, question number 14. Which type of stereoisomerism are shown by 2,4-dimethyl hextuene? So, let me draw this. Hextuene. Hex means 6 carbons, and there are 2 dimethyls. So, 1, 2, 3, 4, 5, 6. 2 methyl and 2, 4, 2 ene. So, double bond on the second carbon. 1 methyl group on second carbon and 1 methyl group on fourth carbon. So here it must have a H, it must have a H, it have a 3 hydrogens, it have a 2 hydrogens, and it have a 3 hydrogen. So if you see over here, you can consider this carbon a chiral one. If it's a chiral one, then optical isomerism can be seen, right? And here there is a 2 carbons with a double bond, and this double bonded carbon have 2 same groups, right? Both the groups are same, and if there are same groups, so it means no cis trans isomerism, right? So in the first part they are saying both cis trans isomerism and optical isomerism. This is wrong, this is correct. So A is a wrong statement, cis trans isomerism only. B is a wrong statement, neither cis trans nor optical isomerism. C is a wrong statement, optical isomerism only. Yes, this is the correct answer. So D is your correct answer. Is this clear to everyone? Okay. So I'm ending the session over here, and inshallah at around 10 o'clock, we will continue with our past paper session today. And then we will take, we will not having any session tomorrow, as you have a exam on 6th, the physics. Okay, you want to continue with the organic only? If everyone is agree, then I will do the organic. It's up to you. Okay. Daniel, Ubaid. Okay. So everyone want to go with the organic. Okay, I'm just going to put a poll on WhatsApp. Then we will continue with the organic thing only. Okay. So we will have a next session at 10 p.m. PST tonight. Okay. And then we will do our next session on not tomorrow, but the day after tomorrow on Tuesday night, because on Wednesday you have exam. Okay. So take care, everyone. Allah Hafiz.